Look at this example. This example gives you various variables. First is the square feet, then the number of rooms, then the number of bathrooms, and then there is the price. Everything, let's say, is in dollars. And how many observations we had? We have around 21 observations. This is the data which is already there with us. So which means that we can see that this is a regression equation. The dependent variable is estimate the price of the flat. And it depends on what? The price of the apartment depends on the total square feet, the number of rooms, the number of bathrooms. These are the three independent variables. So all prices are in dollars. Let's say when the square feet is 4,000 square feet, all prices are not in dollars, only the price is in dollars. When the square feet is 4,000 square feet and number of rooms is 2 and number of bathrooms is 3, the price of the flat is $5,000. Similarly, let me take another observation. When the square feet is 6,700 square feet, number of rooms is 5, number of bathrooms is 3, the price of the flat is 60,000. Now, based on that, I want to estimate one more thing. I want to see if the square feet is 8,000 square feet, number of rooms is 6, number of bathrooms is 3, how much is the price? How much is the price? I want to predict. Price is the dependent variable. I want to predict the price. I want to predict the price of the flat when the square feet, let me take the cursor up, square feet is 8,000 square feet, number of rooms is 6 and number of bathrooms is 3. Similarly, I can predict what is the price when the square feet is 9,000, 10,000, 11,000. So let us see how do we do this prediction using regression. So obviously I have to find out the various coefficients. How many independent variables are there? We see there are 3 independent variables: square feet, number of rooms, and number of bathrooms. So how many coefficients you have to calculate? You have to find out beta 1, beta 2, beta 3. 3 independent variables, 3 coefficients. Then we have to find the y-intercept. When x is 0, what is y? 4 coefficients we have to calculate using the software. So let us see. I go to data. First, I have to add the data pack options. Add in. Analysis tool pack, click. Go. Okay. So this data part has been, I'll just add the data part again. Option. Add-ins. Analysis tool pack. Go. And I'll just click this. Now I click data. Now when I click data, data analysis is coming. I just added this to a plugin. I click data. Various statistical tests will come. And I will just take this regression and say OK. When I say regression OK, it asks me what is the input y range and input x range. Y is the dependent variable, x are the independent variable. So what is my input y range? Price, dependent variable. So I'll choose this. I'll take the cursor here and take this entire column as input y. Similarly, when I take input x, I'll take all the independent variables. There are 3 independent variables: square feet, number of rooms, and number of bathrooms. I'll check the entire data. Then I will say labels, yes, because Excel will not calculate labels because that's integer. I've already written number of square feet, number of bathrooms, so there is not a number. But I've included that in the cell range. So I'll just click Excel label. confidence interval 95% I am doing, and constant is 0. I will say constant is not 0 because there is a y-intercept. I will take the in the new sheet and I'll just say okay. So this is what it comes to. This is what it comes to. Now, if you really see what is the output, let us interpret the output. You can, I'll make it slightly bigger. We are more interested in this coefficients. Now, look at it. First is the intercept. Intercept coefficient is 32271. Square feet, beta 1, 10.59. Number of rooms, intercept is 2286. Number of bathrooms, intercept is -116,249. Before that, we see something which is called R square and adjusted R square. Adjusted R square is 0.88, which means that what is the combined impact of all the independent variables on the dependent variables? It is 0.88 or 88%. That means it's a good regression equation. Adjusted R square simply tells you what is the combined impact of all the independent variables on the dependent variables. That is, what is the combined impact of number of bathrooms, number of rooms, and square feet of area in determining the price of the flat. And that is 88%. Then there is something called Anova table. You see the significant value, which is p value. It is 7.1 into 10 to the power minus 9, which is like 0, almost like 0. What does Anova table do in a regression equation? It actually measures a hypothesis. The null hypothesis says that all the coefficients are 0 or null. The alternate hypothesis says at least one of the coefficients is not 0. And since it is p value is almost 0, we reject the null hypothesis. We select the alternate hypothesis because we took the confidence interval at 95%. P is less than 0.05. And we are rejecting the null hypothesis. We are selecting the alternate hypothesis, which says that at least one of the coefficients is non-zero. Which are the coefficients? These are the coefficients. Now, if one of the coefficients is non-zero, there is a regression equation. If all the coefficients are 0, there is no equation. So that means the model is fit. Anova simply tells you if the alternate hypothesis is correct and null is rejected, it's a fit model. The model is fit. Now let me draw the equation. I want to determine the price of the flat. Price of the flat, let's say, is price. I'll make it slightly bigger once the equation is drawn. Price is equal to, I will take this one, this constant. Price is equal to 32271. This is the constant plus 10.59 into square feet plus 2286 into, I'll just say rooms, plus it will be minus 16249.99 into bathrooms. Just give me a minute, just one second. Okay. Now, let me just expand this equation a little bit.
जो आपने अभी ये वाला पार्ट बताया
नहीं, let me just complete it. इसको जरा expand करता हूँ मैं equation. Now look at this. This is what I have got. Is it clear? Price, which is my y, the dependent variable, is first the constant, which is the y-intercept. Y-intercept is the first coefficient 3221 plus 10.59 is the second coefficient for the square feet. 2286 is the third coefficient for number of rooms, and minus 16249 is the coefficient for number of bathrooms. Now, what was my problem at hand? My problem at hand, coming to sheet 1, is this. I was asked to determine what is the price of the flat when the square feet is 8,000, number of rooms is 6, and number of bathrooms is 3. Now, it is very simple. What is the price of the flat when the number of square feet is 8,000? So it will be 32271 plus 10.59 into square feet. Square feet is 8,000 plus 2286 into number of rooms is 6 minus 16249 into number of bathrooms, which is 2. The price of the flat is coming to $98,209. Where I have taken, when it is 8,000 square feet, number of bathrooms is 6 and number of rooms is 2. Now it is, you can actually predict any square feet, any rooms, any bathroom, and you will get the price. That is what is prediction. Now this is called a multiple regression or multivariate regression. In a simple linear regression, there is one independent variable and one dependent variable. In multiple regression, there is one dependent variable and multiple independent variables. In this case, which are the independent variables? Square feet, number of rooms, number of bathrooms, and price are the. Price is the dependent, and square feet, number of rooms, number of bathrooms are the dependent variable. Independent variables. So that is basically, that's why it's called a multiple regression equation. Also, if you really see this, analyze this entire table, we are getting a adjusted R square as 0.88. The impact of all the independent variables is impacting the dependent variable to the extent of 88%. In Anova table, we are rejecting the null hypothesis, that means the model is fit. And after that, we get the various coefficients. Now, we can do the same thing in any other tool. Excel is one of them. What's your question?
Manually, जैसे हम बोलते हैं कि ये कैलकुलेट करोगे इकोनॉमेट्रिक्स आल्सो कि ये जो आपने फॉर्मूला यूज करके टूल के हिसाब से किया
टूल से आई जस्ट गॉट द कोएफिशिएंट्स बाकी तो मैंने इक्वेशन ही लिख दिया बीटा नॉट प्लस बीटा 1 into x1 plus beta 2 into x2 plus beta 3 into x3. The tool calculated beta naught, beta 1, beta 2, beta 3. x1, x2, x3 आप x1, x2, x3 तो आपका इकोनॉमेट्रिक्स में आपको मिलेगा.
सर तो जो एरर टर्म का होता है हमारे ई जो होता है इसमें वो क्यों नहीं है हमारा
किसमें
हमारे जो एग्जाम में किया.
Well, actually we really don't know what is the error value, because actually when you are taking the, it is basically, it is the line of best fit only, no? It is not passing through all the points.
Yes,
it is only the line of best fit. So there will be some errors always in this equation. We really do not know what is the error. If the software calculates the error as it is, then I know the error, but I don't know the error. So in the theoretical equation, I will mention that there is some error. That means this is not a perfect answer. For example, when I take 8,000 square feet, 6 bathrooms and 2 bedrooms, do you think it will be exactly 98,209? It can be plus minus something. That plus minus something I don't know. The software cannot calculate. That's why I put that there is some error which I don't know.
That's why we like
plus epsilon. It's called epsilon.
Yeah.
So plus I know that there is an error. So when you ask me this question on 8,000 square feet, I give an approximate answer. But as per the regression equation, it is $98,209 plus minus some error. It could be some error. That error term is always there, but the software will not be able to calculate that error. If we can calculate the error, then it is not an error in the first place. Now, let me do something. Let me just use Statcraft and do this. You can use various tools to the same regression equation. We just did that in Excel. Let us do the same thing in Statcraft. So I get the data. I import the data. Give it some name. Housing. Housing. And it is a regression. Upload the file. File is uploaded. And you can see that first thing in regression is all the data is always in a number scale. There is no categorical variable. Dependent variables are numbers, independent variables are numbers. Ratio scale. They're all in ratio scale. And the scales of measurement, it gives me scale. Excel doesn't give you the scales of measurement. Here I can actually change the scales of measurement. Like I can change to nominal, I can change to ordinal. Excel doesn't give me that privilege. So I'll just give it back to scale. All are scales. Okay. So this data is now properly imported. Now I simply go to regression. Do linear regression. Analysis title. Regression. Dependent variables is, what is the dependent variables? Price. What is the independent variables? Number of rooms, number of bathrooms, and square feet. I do OK. So you see, first of all, it gives me the model summary, R square and adjusted R square. We always take adjusted R square. Combined impact of all the independent variables on the dependent variable is 0.88 or 88%, which is a very good model to be. Then we look at the Anova table. P value is 7.16 into 10 to the power of -9. Same results, 0. Null is rejected. Null means that null means all the coefficients are 0. Alternative hypothesis, at least one coefficient is non-zero. It says that at least one coefficient is non-zero. If one of the coefficient is non-zero, that means there is an equation which exists. The model is fit. Now look at the estimates is the coefficient. Beta naught is 32217. That means, which actually means that if the square feet is 0, number of rooms is 0, number of bathrooms is 0, the price of the flat is $32271. Actually, it doesn't make any sense, but we have the observations. If you just extend the line of that observation, it will hit at 32271 intercept, because it is what observations we have taken. 2286 is the coefficient of number of rooms. -16,249 is number of bathroom, and 10.59 is square feet. Then you simply draw the equation. Price is equal to 10.59 into square feet plus 2286 into number of rooms minus 16,249 into number of bathrooms plus 32271. And you can determine any price after that. And it is a good regression equation because the R square is 0.88. So it is actually going to be a good regression equation. So whether you use Excel or whether you use Statcraft or whether you use SPSS or whether you use Python, you will get exactly the same results.